Greetings, Saintsmen. We are going to be proving triangle congruence through the ASA and AAS congruence postulates, okay? Something just to consider as we get started here. Remember when we constructed these triangles? For example, we had this triangle that we were doing here before. Oops, it's not very good. This triangle that we were working with before here. It was triangle ABC, right? And we were constructing this using our compass, right? And we were doing a construction. We had angle D, right? No need to fix that guy. Angle D. And then we were doing is we would copy, right, AB down below. And when we did that, right, we did the copy a segment construction, and then after that we were copying an angle. So we were copying this angle A down here to angle D, okay? So we did this to demonstrate side angle side, and then later we actually showed that when we did side side side, it was effectively like a 2-for-1 construction. The interesting thing here is if I were to copy this angle A simultaneously with this angle B, right? These two angles, right, wherever they meet, they're actually going to create congruent triangles, because when we do that copy and angle construction, remember what we're doing, the side opposite effectively is being constructed. So all we need when we construct triangles to show congruence is the following. Let's go ahead and show DEF, is that if we have these corresponding parts here, right, starting with the side, so we always need at least a side, because, and we've talked about this before, right? That even if we construct this angle, okay, we can't just say 3 sets of angles, because we already had the counterexample of the equilateral triangle, showing that even if we have 3 sets of angles, we need to have one side minimum to sufficiently show that these triangles are going to be congruent. Because if, you know, the issue being, you can make an equilateral triangle with the sides of 1 centimeter and then sides of 1 meter, dramatically different in size, right? One 100 times larger than the other. But the issue is that all the angles are still going to be congruent. So now we're going to show that we have this angle that before was our included angle, right? If we were to show that AC and DF were going to be congruent. But that's not what we're after here. What we're really after here is angle B, right, being congruent to angle E. So now it's not that my angle is included, it's that my side is included. So here is what this is. This is the notion of ASA, which is angle, side, angle. So we can actually prove congruence with just one side, okay? The way that our theory or our postulate goes is that if we have 2 angles and let's go ahead and make that much larger, and the included side of one triangle congruent to 2 angles and the included side of another triangle, then triangles are congruent. And that's what ASA is. So now it's not that our angle is sandwiched or in between 2 sides. Now what you guys are seeing here illustrated is that our side is sandwiched in between 2 angles, and that's sufficient proof. Now, almost as a corollary, right? Remember when we learned about corollaries, it was just going to be something that had a self-evident truth to it. The funny thing is that if angle side angle is, you know, is true, well, think about the following. Think about the fact that the third angle theorem is going to automatically make, when we have 2 sets of congruent angles, going to make the third angle automatically congruent. Okay? So what we can have instead is the following. Let's take 2 more triangles. So we have A, B, C. Congruent to D, E, F. Okay? And what we're going to show is that, remember, let's have our angles set up, right? Well, we have AB congruent to DE. Now, I want you to consider this. Think about how the third angle is automatically congruent, right? So since that's the case, if I were just given this, which is effectively angle, right? Angle, angle, and then the side after that, where the side is not included, this is sufficient proof, because if the two of the angles are congruent, the third one has to be congruent anyway, and I effectively have angle, side, angle. So angle, angle, side, or AAS, is sufficient proof. So here's the best part. We don't need the side to be included. It's going to be congruent either way, but I do need you to identify the difference between the two of these, right? So as long as you have two angles and a side, these two sets of triangles are going to be congruent. They're congruent. There's no way around it, right? But we do need to make sure that we're citing the proper postulate here. So here what angle, angle, side is saying is that if we have two angles and a non-included side of one triangle congruent to two angles and non-included side of another triangle. Let's go ahead and enlarge that here for you. Then triangles are congruent. Okay, let's take a look at a few scenarios. Let me see if I'm going to draw some diagrams. Let's see if you can identify if these triangles are congruent. Okay, these two sets of triangles. Here we go. And we'll even name these things. We'll even name these coordinates. E, F, G, D, and H. Now, are these triangles congruent? That's the question. We have two sets of triangles, okay? Are these two sets of triangles congruent? And the answer is yes, they absolutely are. Because consider this. We have triangle E, F, G, and it's going to be congruent to what? Now, you're thinking here and you're saying, well, we have one set of angles and one set of sides. That's not going to be sufficient proof, right? We need three statements total. It's still going to be the truth, right? Side, 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 angle, side. So far as what we've used, right? Even when we did hypotenuse leg was effectively another form of side, side, side. Okay, through the Pythagorean converse. So now we still need three sets of parts. We need angle, angle, side, or angle, side, angle. And take a look here, because of course we have these vertical angles that are going to be congruent, right? So it's going to be E, F, G, congruent to triangle. Now remember, the parts have to be corresponding. The first coordinate has to be H, right? It's corresponding to E, that right angle. And then to D, the non-vertical angle, and then it's going to be G, so H, D, G, okay? And these are congruent through what? Angle, angle, side, okay? It's technically angle, angle, side. Angle, angle, side, in that order, right? The side, in other words, is not included. Let's do another. Let's take a look. How about P, Q, R, and M. Okay, so all I have marked is PQ and QR being congruent. Are these two triangles congruent? And the answer is they are not. Now you're thinking here, I hope you see automatically, boom, we have this reflexive side. Okay, that's great. But now we only have side side. We either need an included angle, right? Or we need this third side, and we don't have that marked congruent. There's nothing that makes it congruent, okay? So that one doesn't work. Not enough information. Let's go ahead and make here, this is actually mathematically, it's a quadrilateral, you guys see, right? 4 sides. This is actually what's known mathematically as a chevron, for the record. Okay, so it's a concave quadrilateral. Now, let's see if these guys are going to be congruent. And what we have marked is the following. These guys are congruent, and these guys are given as congruent. Are these triangles going to be congruent? And the answer is yes. What we have here is triangle LMP, which is going to be congruent to triangle NMP. Now, all you see right now marked is 2 angles. We need 3 pieces of information. It's always a 3-lettered answer, right? Side, 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 angle, side, angle, and angle, angle, side. We'll take a look. We have a reflexive side here, right? Is that side included? In other words, is it a SA, is the side in between, or is it not included, being angle, angle side? And of course, it's sandwiched in between. So this is the case of angle, side, angle, the included side. So yes, those 2 triangles are congruent. Okay? All we got left here is we're going to do a couple proofs. And that's that. So let's do 2 proofs together here. And I want you guys to remember one of the strategies that I gave you once upon a moon. And as they say, there's more than one way to skin a cat. So we've got a couple ways we can actually accomplish this. Okay? This is H, D. That's a poorly written D. Let's redo that guy. D, E, F, and G. All right, so here's what's given to us. We have these 2 sets of sides that are going to be parallel, and these 2 sets of sides that are congruent. Okay, so here's our given. We are given that DH is parallel to FG. Moreover, that DE is congruent to EG, and we are going to prove congruence here. It's going to be triangle DEH congruent to triangle GEF. Okay. So let's go ahead and give this a shot. Now remember, think about the strategies I discussed with you guys, okay? They love to do 2 things. Geometry books are not very creative. They love 2 things. One, when you see parallels, you should be looking for alternate interiors, okay? The other one is that if you see any sort of intersection like this, you're going to see vertical angles, okay? So let's go ahead and see if we can use that information to our advantage here in our 2-column proof. Remember what we need total. We need 3 sets of congruent statements. Right now, from our given, we only have 1, okay? So let's go ahead and rewrite this guy. And that is our given, okay? Now step 2, doesn't matter the order we do this in, okay? I'd like for us to consider this guy, right? Let's go ahead and take a look and see that these angles are going to be congruent, right? So in other words, don't just say angle E. It's technically angle DEH, and it's going to be congruent to FEG, where E, of course, is the vertex, right? It's the point that's listed in the middle. This guy, These guys are congruent because of vertical angles. Okay, so look at what we have here. We have two sets of congruent statements. We need two more. So, because of our parallel lines, we can say we have alternate interiors. There's two ways to go about this, okay? I'm going to actually just go with this guy D and this guy G, okay? So angle D congruent with angle G. And again, because I saw those parallels, it makes me know that these guys are going to be alternate interiors, and that's why they are congruent, okay? The transversal in this case is DG, right? So now look, let's go ahead and mark those. This guy congruent to this guy, okay? I love to mark my diagrams, as you guys know. It makes it much more visual. And then again, I'm going to take inventory of the number of congruent statements. I have 3 of them. But now we need to decipher, why are my two triangles, right? Because we're set here. We have enough information with two congruent statements. Okay, so we have two sets, and it makes these congruent, but we need to cite the proper thing. It's going to be two angles and a side. The question is the side sandwiched in between the two angles? And the answer is yes, it is. So here, the reason why is that is because of ASA. And we literally write the side in between the two angles. I hope that this is intuitive for you guys in terms of when it's included, sandwiched in between or not. Okay? Let's do another one. One more proof. Here we go. Ooh, this is a fun one. And this is F G H and K. And here's what we're given. Given that angles F and K are right angles, and that FH and GK are parallel. And what we are going to prove is that triangle HFG is going to be congruent to triangle GKH. It's so important here that we're utilizing the proper citation as to why things are going to be congruent, especially in the end, okay? Because we've done proofs like this already, right? Where we've shown that, oh, okay, well, we have right angles, right? So all right angles are congruent, okay? Of course, I'm just doing rewriting my given here. Okay, right now I have zero, I have nothing that proves this congruent, okay? Now, there's two ways I could do this, okay? I could actually do this through angle, side, angle, but I'm gonna wind up doing angle, angle, side. It just matters which set of congruent statements that I provide. Now, one of the things that I know right away is that F and K are going to be congruent because, again, we've used this reasoning several times now, and it's all right angles are going to be congruent, okay? So there we go. One set of congruent statements down. I think we always like this one too. This one's usually becoming obvious for us, where we have HG congruent to itself because of the reflexive property, right? Again, we've found so much utility in that reflexive property. Last but not least, we need another angle, right? So we right now have these two, the right angles, which they look like they're marked, right? But because of the right angles, they have the little box so that it's the same, but it's not explicitly, right? We have to make sure that we have the actual congruent statement. So we have an angle and a side. Now think about what we have. Remember, we have the parallels. So what does that result in? It's this, guys. It's that we have these alternate interiors. So angle FHG congruent to KGH. And these guys are alternate interiors. Think about what we have here. 1, 2, 3. We have a sufficient number. Now we have to make the proper citation here, okay? Because this is not side angle side, right? That's where people will say, oh, I see parallels, so those are congruent. No. I mean, let's be specific. You can't just use whatever reasons you want, okay? That's sloppy. So here we have an angle, and then the side afterwards, right? So that's where we're going to make our case. Okay, the angle, and the side. Those right angles congruent. So it's HFG. The side is not sandwiched in between the two angles, okay? And it is going to be congruent to GKH. Why? Angle, side. Side is not included, and that's okay. Now, gentlemen, think about this. We could have gone one more step here. We actually could have said not only were these congruent, but also these angles here, right? FGH and KHG are going to be congruent. Also, because of alternate interiors, we could have extended step 4 that way. Now look at what we could technically do. We could have gone through and done angle, side, angle, right? Or we could have actually said, okay, well, not only are those alternate interiors, but again, these GHK and FGH are going to be GHK, yes, and FGH. Okay, I said it correctly. Those two are going to be congruent because of third angle theorem, right? Because we already have two sets of congruent angles. That's fine. That's still going to give us angle, side, angle. But that's not what we've cited here in the evidence that we've used, okay? So we need to be specific as to the evidence that we're citing for our reasoning. So there we go. That's it. That's all I got for you. Your assignment is posted on Canvas. Good luck.